Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Haziq bin Edwan and my metric number is CE1900-3. So I'm from the group 2. So I will talk about the introduction and the conclusion. So for the introduction of the project, we I will explain the digital signal before going to the two things that we use in this project. So digital signal processing is to carry out the broad range of signal processing tasks, such as by computer, or we can call for the specialized digital signal processor. So the digital signal collection of number that represent sample of continuous variable in either the time space or frequency domain. A pulse rate, which is frequently produced by transistor switching, is it is how a digital signal is represented in electronics. So there are two subfields of signal processing: digital signal processing and analog signal processing. So in this project, we are focusing on the digital signal processing, which is we are using the IIR and FIR filter. So uh, other applications include audio and speech processing, statistical signal processing, spectral density estimation, digital image processing, data comprehension, and data management. So they are both linear and non-linear digital signal processing procedure. So non-linear system identification is connected to non-linear signal processing, which can be used in the time, frequency, and temporal domain. So I will talk about the IR filter, which is meant by the IR filter is an infinite impulse response filter. So this generally chosen for application where linear phase is not too important and memory is limited. So this IIR filter has been widely deployed in audio equalization, biomedical sensor signal processing, IoT, smart sensor, and high-speed telecommunication application. So they are also have advantage and disadvantage of the IR filter. So for the advantage, this is low implementation cost and low latency, and analog equivalents may be used for mimicking the characteristic of analog filter using S to Z plane mapping transform. So for the disadvantages of IIR filter, so there's no linear phase characteristic, more detailed analysis, and the numerical stabilities. So for the FIR filter, um, so FIR filter is a finite impulse response filter. So these are chosen for application where linear phase is important and a decent amount of memory and computational performance are available. So this is very different with the IR filter, where IR filter is a limited memory and also is for non-linear. For this one is linear phase. They have been widely deployed in audio and biomedical signal enhancement application. They all zero structure and to ensure that they never become unstable for any type of input signal. So this give the FIR filter is more advantage of the over the IR filter. So also they have advantages and disadvantages for the FIR filter. Where is the FIR filter? There's a linear phase, stability, arbitrary frequency response, and fixed point performance for the disadvantages. So this high computational and memory requirement, high latency, and minimum phase filter. And the last one is not analog equivalent. This means that filter can be easily be transformed into an equivalent IIR filter only, so not for the FIR filter. However, this is not possible for an FIR as it has no analog equivalent. So, thank you.
Assalamualaikum. My name is Muhammad Helmi Roslan. My number metric DE190007. Okay, for my part is the problem statement that you can see here. During the noise interface is knowable in digital design. So we obtain the signal that we filter because the noise have the interference. So we use the MATLAB for filter the signal using two fundamental type, which is FIR, infinite impulse response, and IIR, infinite impulse response. So we identify the challenges, the filter, and then the filter is one most important method signal processing, removing noise and allowing the information in signal to recover readily. So our objective is we learn how to use IIR filter, the signal lowest frequency. Next, we learn how to reduce noise from the audio signal. Then we learn how to apply the Z transform approach with FIR and IRR filter in MATLAB. And then lastly, we understand how to calculate FIR filter using theory and concept. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Rizal bin Muhammad Zubir and my matrix number is DE190127. Okay, now I'll be explaining about methodology. Okay, first of all is signal filtering. Okay, to solve the problem, we must first compute or calculate the output of the signal of the system using the convolution approach, and then using discrete Fourier transform technique. First, we will encode the signal in frequency domain prior to to visualize it, and then for the discrete time signal consisting of a sequence of real or complex value into a complex frequency domain. For the software we are using is a MATLAB software. Okay, MATLAB software is for the evaluate the digital filters ranging from fundamental single low pass and high pass design to more complex FIR and IIR design. Okay, signal processing toolbox offer function and application for managing, analyzing, pre-processing and assessing characteristic from uniformly sampled and non-uniformly sampled of the signal. Next is the toolkit contains instrument for filter construction and analysis resampling, smoothing, detrending, and estimate the power of spectrum. Okay, now I will explaining about our flowchart for the project. Okay, from start, which is we need to launch the MATLAB software with signal process toolbox installed, and then we need to load m.mat .mat files. .mat files we can get from Excel files that given by Dr. Ariffuddin and convert it into .mat files as a files value. Okay. Next is we need to calculate the x equal to first Fourier transform. Okay. From this part we need to divide it into two partition, which is IIR and FIR. Okay. First for the IIR. Okay, first thing we need to do is convert the zero point gain filter parameter into the transfer function, and then next we need to apply the analog to digital conversion to get the accurate value, and next is to obtain the signal. Okay, from the value of the signal, we can plot the graph for the IIR. Okay, next for the FIR, first process we need to do is find the value of sampling rate. Okay, after that, we can apply a Chebyshev window. Okay, this can be used as a Chebyshev is the present of the impulse at the endpoint of the time domain response. Okay, after we can get the value, we can proceed to plot the graph using the code program of the MATLAB. Okay, after we get all of the graph, we can end the program. Just save and close the MATLAB. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farhanatullah binti Nurifai. Entry number is DE193054. For this DSP project, I will explain the solution for FIR filter and II filter. Okay, first is we get the data from the lecture in the Excel format. Then we need to convert it to be used in MATLAB. We use load to read the data. Second is before filter, we need to DFT the signal, and lastly, we need to filter the data to get the clear sound. Okay, and I will run the coding by section so that we can hear the sound before filter and after filter. First is before filter. From the signal, we can see that the amplitude for the waveform is almost reached 2, and the waveform is also compact. Okay, next is for DFT technique. Okay, as you can see, for DFT technique, the signal is still compact. For the magnetic spectrum, Okay. The magnitude is 410000 and the y is 1. Okay. Last is field FIR. This the signal is the original signal and the filter signal. Okay, as you can see, there is a difference of the original signal and filter signal. The amplitude after the filter it only reach till 1, and the waveform also less compact than the original. Next is for the IIR filter. We use the same data as FIR filter. And next is the coding for the IIR filter. We use the ellipse window to filter our signal. And I will run a bisection to hear the difference between before and after. Okay, as you can see, the signal for the data IIR, the amplitude is 2 and the waveform is more compact. This is the magnetic spectrum. The amplitude for the magnetic spectrum is X20499 and Y is 1. This is before filter the signal. Next, we see after filter the signal. After we filter the noise, we can hear the sound very clearly without interrupt from the noise. This is a filter signal and the IIR filter. You can see the amplitude is below than 1. I think the highest is 0.8, and the waveform is less compact for the magnetic spectrum. The amplitude is 0.03 compared to the before the magnetic spectrum is 1. And this is the magnetic response in dB for the elliptic filter. I think that's all from me. Thank you.
For the conclusion, I will talk about our project. So anything that contains information is referred to as a signal by digital signal processor. So it may also be described as a physical quantities that change with time, temperature, pressure, or any other independent variable like as a speech, audio, video, temperature, pressure, or location, and mathematically manipulate them. So in this project, we are making the IR and FIR vector. We will evaluate in terms of magnitude response, magnitude spectrum, convolution, phase spectrum, and minimal filtering in order to reach near optimal filter response. So following that, we are also given a problem and must solve the signal spectrum using the Z transform method to produce the signal. We learn the calculation process and approach by using MATLAB to construct two filters, which is FIR and IIR filter. So that's all from me. Thank you.